Dear students, once again I welcome you all for another interesting session on Introduction to Three-Phase System. Start the session with an interesting quote. Electricity is a good servant but a bad master. You control electricity, it will serve you nicely, but do not ever allow it to control you. With this quote, let us let us see the contents of this video session. We will be discussing about what is alternating current, and then what are the different power supply systems are available, like single phase and three phase. We will describe what is a single phase system and three phase system, and in a three phase system what is the balanced voltage and what is an unbalanced voltage, and finally we will discuss about the phase sequence of three phase supply. Alternating current, so shortly it is called AC. The AC stands for alternating current. So how to describe this alternating current? So alternating current is one whose magnitude changes continuously with respect to time. You can see here nowhere the magnitude of the waveform is constant. This is a voltage waveform drawn with respect to time. So continuously the voltage is increasing from 0, it reaches peak value and then comes back to 0 and goes to negative peak and then comes back to 0 and so on. So the magnitude of the alternating waveform is continuously changing, and the number 2 is periodically the polarity is changing. So you can see this is the positive polarity and this is negative polarity. You can see here for some time, that is from 0 to 180 degree, the alternating current is positive, and then for another 180 degree it is negative. So the alternating waveform changes its polarity periodically. Suppose if it is a 50 Hz waveform, 1 by 50 will be 20 milliseconds for completing one cycle. It means that for 10 milliseconds the waveform is positive, and for another 10 milliseconds the waveform is negative. So as a whole you can describe this alternating current as one whose magnitude is changing continuously and the polarity changing periodically. So at this juncture I would like to introduce Mr. Nikola Tesla, who is a Serbian come American inventor who has contributed a lot for the development of alternating current systems which are widely used nowadays by all of us. He has also discovered the concept called rotating magnetic field. And the AC power supply systems are classified into two main things, that is single phase AC supply and three phase AC supply. So single phase supplies are used in wherever low power requirements are there, and for high power requirements three phase supply is used. Now let us describe what is a single phase supply. So in a single phase supply there is only one voltage produced across two wires. Those two wires are called, one is phase and the other one is neutral. So in India we specify this single phase supply like 230 volt 50 Hertz. So 230 volt 50 Hertz is the specification of single phase supply in India. This is an animation that shows how single phase supply is produced. So consider a magnet, a permanent magnet is producing magnetic field from top to bottom, and in between this magnetic field a single turn coil, this is what single turn coil is being rotated in anti-clockwise direction. So as per Faraday's law, so whenever a conductor is linked by a magnetic field which is changing, an EMF or voltage is induced across the coil. So these are the two ends of the coil which is connected to a galvanometer. This left hand side is negative and right hand side is positive, and this is 0. You can see here, when for a half rotation of this coil the voltage is positive. For the remaining half rotation of the coil the voltage will be, you can see, negative. So that is what drawn as a waveform with respect to time. Here positive, negative, and this follows sine function. Hence it is a sinusoidal waveform. So this is how a single phase AC voltage can be generated, and this is a simple way of expressing. Now let us describe what is a three-phase supply. So in a three-phase supply there are three voltages generated across 3 or 4 wires, and those 4 wires are called red, yellow, blue, and finally neutral. And these three voltages are equal in magnitude. The height or the peak value of all the waveforms will be same, and they are displaced from each other by 180 exactly. And in three-phase supply there are different voltage levels available, starting from 11 kV, 33 kV, 66 kV, 230 kV, 765 kV. There are different voltage levels available with 50 Hz frequency. Now let's see how this three-phase voltage is generated. So here we use three coils, that is R, Y, B. They are stationary part of the machine, and in between a permanent magnet or an electromagnet is rotated in anti-clockwise direction. So the magnetic field produced by this magnet, when links with each coil, three different waveforms or three different voltages are induced. Now you can see the red phase starts from 0. Let us take this as a reference. It starts from 0 and it goes on with 50 Hz frequency. And you can see the yellow phase starts 120 after the red phase starts. Here you can see yellow phase starts at 120, and again the magnitude is same as your red phase. Then you consider blue phase. Blue phase starts 120 after the yellow starts, and also 240 after red starts. And again the magnitude of the blue phase also will be same as your R and Y phase. Now you can notice that the three waveforms are displaced by 120 each other. So this is how you can describe a three-phase AC voltage. This is how AC power generation is done. So as I said before, a permanent magnet or an electromagnet is being rotated, and when this magnetic field links with each coil, some voltage is induced like this. A three-phase voltage is induced, and this is how we represent the three voltages. So voltage across R and Y phase is taken as reference, that is Vm sine omega t. Since it is following sine function, we write it as Vm sine omega t. And the voltage, second voltage, is Vyb, which is 120 delayed from R phase, therefore we write minus 120. And B phase, sorry, this is actually VBR, not Vyb, VBR, which is Vm sine omega t minus 240. From R phase, this B phase is displaced by 240, therefore you can see here 240, therefore minus 240. And now let us see what is a balanced three-phase voltage. So this is the three-phase waveform. So this waveform is said to be balanced when all the three phases are equal in magnitude, that is the peak value will be same for all the three waveforms, and they are displaced by 120 exactly from each other. So if all the three phases are having same magnitude and they are displaced by exactly 120 degree, I will call this waveform as a balanced three-phase voltage. Unbalanced three-phase voltage. In an unbalanced three-phase voltage, the height of each waveform or the magnitude of each waveform will be different. You can see the three waveforms are having different peak values, and they are not exactly displaced by 120 degree. So R phase starts here and Y phase starts after 120 degree, and blue phase starts, the gap between Y and blue is less than 120 degree. So the displacement is not exactly 120 degree. So magnitude is different and the displacement is also different. In such case, we will call this as a unbalanced three-phase voltage. This is the phase sequence. So we know that the three voltages are VRY, VYB, VBY. It means that the voltage measured between R phase and Y phase is VRY and so on. So the order in which these voltages are generated is called phase sequence. So which comes first or which comes next, so that will decide the phase sequence. So basically there are two different phase sequences possible. So they are RYB and then RBY. It means that R phase starts first, 120 degree later Y phase starts, and again 120 degree later B phase starts. In another phase sequence, R comes first, B comes second, and Y comes third. So these are the two possible phase sequences possible. And this is how we represent the phase sequence. In RYB phase sequence, VRN, VYN, VBN. So Y is 120 degree displaced from R and B is 240 degree displaced from R. And this is how we represent the three phase voltages using vector diagram. This is a reference, and assume that this is rotating in clockwise direction. So between R and Y there is a 120 degree delay, and again there is a 120 degree delay between Y and B, and so on. For the next sequence RBY, R comes first, B comes next, and then Y comes. So here R, B, and then Y. So this displacement is represented using these angles. So this is how the two phase sequences are described. So please remember these balanced voltage, unbalanced voltage, and phase as basics. Thank you.